mean, in the industry, they usually use the semi-direct method because there is can get more information about the soil. And how about the different type of the drill rigs that we use usually?
That's a great question. I was thinking about it too. And what about the drilling technique commonly used?
That's right.
There must be different method. Depending on the site condition.
Let us ask the DRA2523 study as well as geotechnical issue about this.
Yes, let's go. Hi Emma. We were just talking about the drilling.
Yeah, probably you will know about this.
Now it's explore the subsurface, but we're really curious about the types of drill rigs and the drilling technique used in practice.
Yes, absolutely. There are several types of drill rigs and they're selected based on the site condition and drilling requirements. The main types include truck-mounted rigs, also called highway rigs. These are commonly used for easy access, location where the rig can be driven onto the site. And then off-road mounted rigs used for rough or uneven terrain where truck-mounted rig can operate. And then the last, trailer mounted portable rig. These are lightweight and used in remote areas where the transportation is challenging.
This makes sense. I know the truck mount rigs and it is widely used because they are mobile and easy to set up. The process is starting by positioning the rig at the drilling locations and erecting the drilling bomb we call as a mast to ensure it is vertical, and then using the drill head mount on the bomb to perform the drilling operations.
Exactly, the drill head provides two exceptional motion. The first is rotational force to turn the drill bit. The second one is vertical thrust to raise and lower the drill bit and other equipment.
Now let's talk about the drilling techniques. One common method used in our country is rotary wash boring, also known as wash boring. This method is effective for drilling through loose soil like sand or gravel. It works by pumping water or drilling fluid, usually mixture of benttonate water and also polymer water, which down the drill pipe to break up the soil and carry the cuttings to the surface.
That's interesting. And I've been in the rotary wash boring, and usually the end of the casing also will be inserted into the borehole to prevent the collapse. And the drilling process also continue until the desired depth, which is follow the specification, the termination criteria that is specified by the JKR borehole and rock terminations.
So that means by using the truck mounted rig and wash boring method, we can successfully drill borehole to determine the subsurface condition. This helps us identify the geomaterials beneath the surface, their thickness and their characteristics. For example, cohesive soil are classified as soft, steep and hard, while non-cohesive soils are either dense or loose.
That's correct.
Exactly, and during drilling, we must follow relevant standards and codes of practice to ensure proper procedure and data accuracy. This includes MS 2038-2006 Site Investigation Code of Practice, JKR Standard Specification for Road Works, Section 70, Harbour Site Investigation Requirement, and BSE and ISO 224751 2006 Geotechnical Investigation and Testing Sampling Methods and Groundwater Measurements. These standards guide drilling practice safety and data recording.
So in summary, drilling requires selecting the right drilling types and based on the site conditions, and we need to make sure that we use a suitable drilling techniques, and also for sure we need to follow the industry standard. And in conclusion, for making the borehole, and then all the detail in the borehole will be recorded in the bore log.
Have you guys seen this video?
Wow, this is a great video.
Yeah, interesting.
Guys, I think we have been sitting in long enough. Let's go over there to take some fresh air.
Let's go.
You guys wonder what happened during sampling? I mean, the brief procedure.
I'm also curious. What do you think, Tay?
Yes, I do. I learned from the researcher YouTube video, and the sampling is a process that collecting the sample beneath the surface using the sampler, and it also can be classified into two, which the disturbed sample and undisturbed sample.
I have heard about it before. Disturbed sample, these are collected when soil strata change or at specific depth intervals using a dribble sample, like a split spoon sample.
Great! This topic is getting interesting. Let's sit over there and we talk about it more. Right, this method is commonly used in standard penetration tests where the sampler is driven into the soil using a hammer. The collected soil is then stored immediately into airtight polythene bags and labeled for identification.
Since the disturbed sample don't retain their natural structure, they are mainly used for laboratory testing and to determine the property, the soil property like the moisture content, the artificial limit, and also for sure for the safe analysis.
Now for undisturbed sample, we use a push sampler, like a thin wall tube sampler, U2.5. This method is used in corrosive soil like clay and silt to preserve their natural structure.
Yes, the tube is pushed smoothly into the soil to minimize disturbance. Once collected, the sample is sealed with 40 mm non-shrinking wax to retain moisture and prevent structural damage.
And for storage, the undisturbed sample must be deep dried, covered, and handled carefully to avoid deformation during transport.
To ensure proper safety procedures, we follow industry standard like MS 2008, 2006 Site Investigation Code of Practice, and second one is BT Standard ISO 22475 Part 1 2006, which is Geotechnical Investigation and Testing. These standards help maintain consistency and accuracy in soil investigation.
So, in summary, we collect disturbed samples using a driven sampler, split spool sampler for laboratory analysis, while undisturbed samples are taken using a push sampler, thin wall tube to preserve in situ soil properties. Both are essential in geotechnical investigation to understand subsurface condition accurately.
Exactly. The sampling is a very important process.
I agree.
Guys, look at this. I found this by scrolling my TikTok.
Oh. Wow, this is amazing.
Yeah, right? And also make me more understand about this topic again.
Yeah, it's very informative by the way. Yeah, I really agree about it. We have been talking about drilling and soil sampling. What about ECT test? Do they test the soil on site or do they take the sample to the lab?
Good questions. The institute tests are usually conducted directly at the site, which the institute test usually we use to determine the soil's strength, bearing capacity, and also the density. And for the laboratory testing, usually we will take the sample from the site and transport it to the laboratory to determine the soil property like the artificial limit, the moisture content, the bulk density, the gas density, and also for the specific gravity.
Exactly. Some in common institute tests include standard penetration test, groundwater level test, Macintosh probe test, hand auger test, and also vein shear test. Each one has its purpose and follows specific standards.
And for standard penetration test, used to assess soil density and strength, especially for foundation design. Here is how it's done. First, position a tripod over the borehole and then attach the split spool sample to the drill row and lower it to the test depth. Third is drop a 63.5 kg hammer from 75 cm and count the number of blows needed to drive the sampler to 30 cm. The standard penetration test and value is recorded from the last 30 cm penetration. Number 5 is if more than 50 blows are required for 50 cm is called reserve. And number 6, the last one is apply correction like overburden correction and delinquency correction. So for the standard, we use British Standard 1377 Part 9 1990 institute test, and the second one is MS 1056 2005, which is soils for civil engineering.
Yeah, and for the groundwater level test, measuring groundwater level is important, especially for deep excavation or foundation work. First, we use an electric meter to detect water level inside a borehole, and when the probe touches water, the signal is triggered, and the depth is recorded from the ground surface, and the measurement are taken during drilling after 24 hours or even week later for accuracy. And for standard, we use MS 2038-2006 Site Investigation Code of Practice and British Standard 5930-2015 Code of Practice for Ground Investigation.
The third test that we usually conduct at the site is the marking stone prawns test, which in this test, the test is indirect and is low cost and quick to assess the soil's consistency. And when conducting the marking stone prawn test, we will drop a 4.5 kg hammer from the 30 cm to drive a coil into the ground and count the number of blows from every 0.3 meter penetrations. The test stop, and the test will start at the 400 blow per 0.3 meters or 12 meter depth, whichever will come first. And usually the industry standard route that we will be follow is the JKR standard specifications for road work, which the sections the 70, and also the Malaysia standard, the MS 2038 and 2006, which the site investigations.
The fourth is vent shear test. Definitely, the vent shear test is used to determine the undrained shear strength of soft clay. So number one is a four-bladed. The vent is inserted into soil at a specific depth. Number two is it is rotated slowly until the soil fills. Three, a torque measuring device called the force needed, which help calculate shear strength. After fixed shear strength, the vent is spun quickly to measure residual shear strength. So the standard that we follow is ISO 22476 Part 9 2009 Geotechnical investigation, and the second one is ASTM D2573 Part 22.
So the last one is hand auger test. It is simple way and manual way to extract soil sample. First, we rotate 73 mm diameter I1 auger into the soil. When it reaches the desired depth, leave it to remove soil sample, and then samples are collected every 1 meter up to maximum depth of 5 meter. That's for soft cohesive soil or sandy silt above groundwater level. And for the industry standard, we use 8 STM D1452. 21 soil exploration by auger boring, and number 2 is we use Malaysian standard 2028 2006 site investigation.
So, in situ testing are super useful because they get the real-time result without waiting for the laboratory results. And this also help the engineer to decide whether the soil is strong enough for constructions or if the additional foundation support is needed, so that we can make sure the structure do not settlement or collapse.
And you know the best part is, this test follow international standards like British Standard 1377, ASTM, ISO, and JKR spec. So the results are reliable and consistent.
Yeah, this is actually
Agree, right?
that's very informative.
Let me clear right now.
Alright.